And what's necessary in order to think and to grow and to learn? We got to what? We got to think, we got to communicate, and we got to collaborate. Guys, we need to get our vertical surfaces when we're working through problems. I see multiple groups where there's 1 to 2 people who have the idea, and then there's a third person who's sitting there doing nothing. Guys, that's not how we learn. We learn by talking, by communicating, by making sense of these things. So first off, looking at this, right, we can even see Miles got up, wrote it, right? Taylor got up and wrote it. We see some work over here from the Jacks, right? When I have negative 12 is equal to a times 0 plus 2 times 0 minus 3. And I also want to make this note. I saw a lot of us who had work from yesterday with 0 explanation. If you don't explain why, you're not going to be able to use that information in the future. Where did this equation come from? How do we go from here to here? What's that step? Substitute what? Hey guys, what do we have to identify? Maybe a point. What point did we use? So not an x-intercept, we did use the y-intercept, right? It was on the y-axis. So we got a point there. So how do we get to this equation? So we had to ID a point. How do we get to that next equation? Substitute what? So substitute 0 for what? Isn't it literally an x value? It's an input. And if I substitute 0 into my input, I'm going to substitute negative 12 for y, or what's another notation that we have up there? What is it? The output. But what's the notation we have? F of x. Right? Isn't f of x the same as y? It's my output, right? So I substituted those two things in. That's the explanation that we should have been writing down to make sure this makes sense. And now I have an equation. How many variables, how many unknowns, I should say it that way, how many unknowns are in that equation? 1. When you have one unknown, what can you do? What is it? Solve, right? You've been doing solving equations since 6th, 7th, 8th grade, right? If you got one variable, what can you do? Solve. Now remember, my recommendation is to do what before you start using inverses? It's another S word. Simplify that joker. Make your life as simple as possible. Simplify it. Then, after we simplify, what do we use? Guys, you've used inverses the whole time you've been solving equations, yeah? Yes? Hopefully? Yeah. That requires that we identify what's there. Okay, so simplify. What's 0 plus 2? 2. What's 0 minus 3? Can I simplify this further? I would say that's negative 6, isn't it? And then don't forget, now it's as simple as it gets. 1, could you look at this and know A is 2? Negative 6 times what gives me negative 12? 2, right? Like you can do that, okay? But also, what is happening between the negative 6 and the A? They're being, so what do I need to undo that? 2 is equal to A. That's it. Now I'm going to go back, I'm going to write my equation. What was A? 2. Now, I'm going to pause for, so don't write anything down yet. I do want you to take notes out of these things, and we got to know this inside out and understand how to solve an equation. But I want to pause and I wanted to point out, we used the point 0, negative 12, yeah? But there are 3 other clear points that I can see in that graph. I can see the point 1, negative 12, I can see the point negative 1, negative 8, and I can clearly see 2, negative 8. And no matter which one I used, at the end, when I finished solving, what did I get for A? So does it matter which point you use? Not even not really. It's the same function, isn't it? So no matter what point you use, it'll give you a. It is the same function. So don't stress about which point to use. Just identify one other point, substitute your x and y values in, then solve that equation. Right? Substitute another point in, solve your equation. That's how we find a. What are your questions about that? So you have a decent bit of space there. Make what notes you need to, not just having the process, not just having the steps we took, but the explanation of why we took those steps to make sure that you understand why later. If you understand why, these things make a whole lot more sense. You can write it on your Fair model, you can write it on this paper, whichever you want. Okay? After you finish writing your notes, I want you to go to your vertical surfaces, and I want you to find the standard form for that equation that we just wrote. So once you finish writing those notes, I want you as a group to go to your vertical surface and find the standard form of that equation. And then if you finish that before we come back together, move on to number 2. So if y'all can just wait a second for people to get their notes of that, then go up there. Okay, so go ahead and start talking and work on these things up. Sorry, I forgot to turn that TV on.
It's okay.
Thanks. I appreciate it. Appreciate it. You're very close. Thank you. Thank you. Okay, so I want to have a quick conversation with some of us. So if y'all move to the center, I just want to point out a couple of things. When we are done, we shouldn't just be pretty confident. We should know that we have the correct standard form, right? Yeah. So I want to remind you, and I want to point this out, because some of us have different answers. I see 2x squared minus x minus 6. I see x squared minus 1x minus 6. I see 2x squared minus 2x minus 12. But this equation, whichever one it is, and this equation, by the way, don't forget it equals f of x. We always need our output in there. Those two equations, whoever is right, those two equations should be what? Equal. Did you say equal? Equivalent, right? Remember, they're not exactly equal, but they are equivalent. They look different, but they are telling the same story. How could I check easily to make sure my two equations are equivalent?
It's the same.
How do you know when they're the same?
Graphing.
Say it again.
Graphing.
Could I graph them both?
Yeah.
All right, so let's grab a calculator. Not y'all right now, but in the future, when you're checking equivalence, make sure you grab a calculator. No, come back. All right, so I'm going to add a graph page. Notice it comes up. Y'all can't see that because my computer hates me. I probably need to turn it off and turn it back on. But the original equation was 2 times x plus 2, right? Times x minus 3. So let's check the x squared. By the way, don't forget, how do we do cool crap on these calculators? Menu. Where do you go now?
Entry.
Yeah, graph entry / edit and function. As long as it's y equals or f of x equals, you're good to go. So x squared minus x plus, nope, minus 6, right? Is that what we had over here? Are those two things equivalent? Do they perfectly match? Notice they have the same roots, don't they?
Yeah.
But not quite. So now we want to test the 2x squared minus 6, or minus x minus 6. Are those equivalent? Notice they don't even have the same roots, do they? So let's check the 2x squared minus 2x minus 12. Are those equivalent? Exactly the same graphs. So what is it that some of us were forgetting? To distribute. Notice that 2 is not just on the x squared. X plus 2 times x minus 3 was x squared minus 1x minus 6. But what is in front of all of that? The 2. And so if I distribute that 2, then I get equivalent equations. Okay? Check yourself. I will point this out on a test. For stuff like this, you're going to have a calculator. On the test and on demonstrated understanding, when it's just, hey, identify these features, you're not going to have a calculator because I want to see that you know the equations and you know how to identify the features. So there will be a non-calculator portion of this test. But on this, you will have a calculator. If you check yourself and you're like, oh, I got this wrong and I know they're not equivalent, is that evidence that you understand what's going on? Yeah, you can make that note. And if you don't have time to fix it, I still know that you understand what equivalence is. If you want to take the time to say, hey, Mr. Kenny, I graphed both of these and they map to each other, right? They're identical, so they're equivalent. That's pretty good evidence. In fact, part of your proficiency scale is being able to identify equivalent functions. That's something to consider. What are your questions about this? Going once, going twice. Sold. All right. Let's move on to the next graph. If you realize, hey, Mr. Kenny, I still have a question, ask me or ask your group. This is the graph we should be looking at now. The second graph there. What are your questions? Ready, set, go. That's a great way to start. Ask your group first. Negative concavity. I don't think you can have negative concavity. It's concave what? Down. So what's with this? But I do want to emphasize and remind you, pay attention to what form you can use. I know that some people started on factored form with this one. Why can we not use factored form in this problem?
It doesn't have two.
Yeah, we don't have roots. How do we know if we have roots?
X-intercepts.
Right, the roots connect to those x-intercepts. I don't have an x-intercept, I'm not using a factored form. But what point do I have? What point can I clearly identify? Your vertex, right? So start with that idea. And again, you can write out that general form first. That's going to help you remember some things. That's -3, -4.
Yeah, something like that.
So does it matter what point you use from there?
Nah.
Notice I don't have a clear y-intercept, so I'm not going to use that point. These are the points that you could use. Doesn't matter what point you substitute in, what's A going to end up being? -1/2. Now I want to caution you and I want to emphasize something. I saw several of us do this and I get it. I didn't expect it, but I get it. Where they put a negative here in front of A. And this can kind of work out, but why would we put a negative in front of A? Because the parabola is concave down. However, if you do that, that comes out with a positive A. Just leave it as A. It'll work out naturally, right? And we get a -1/2 in there. What are your questions about that? Questions going once? Questions going twice? Questions are sold. Now, I'm skipping this one. I'll provide some solutions for this later. But I do want to point this out with this graph. Which form could you use in this function?
Factored.
Factored? Can I use factored form?
Yeah.
Yes?
You can.
I can. Okay. Why can I use factored form? I've got roots. I've got x-intercepts in there. Could I use vertex form? Why? I have a clear vertex, right? So there's sometimes when you can only use one or the other, and then sometimes you choose your own adventure, right? So keep that in mind. And so with this table here, I want to ask you this. Is it hard sometimes to see from the table what we might want to use? Maybe. If you're uncomfortable with the table, what can you do? We practiced using graphs, haven't we? Now I will ask this to help you all get started. Could I use factored form in this one?
Yeah.
Where? The 1 and the 3 are my what? Close. Roots. It's not the same thing. The 1 and the 3 are roots. What's my x-intercept? Remember, there's a point for x-intercepts, a point for y-intercepts. Right? So 3, 0. So you can use that. Now, so you can use factored form. Could you use vertex form?
Yes.
Where do you see the vertex?
-2.
Isn't the vertex a point?
2, -2.
2, -2. Why would this be my vertex?
It's the lowest point.
It's the lowest point, maybe. There's an S word that I'm looking for. It's symmetrical, isn't it? Isn't there symmetry around my vertex? If I graph this, you know what's going to be right here? Symmetry around this point. So keep that in mind. I didn't tell you it was the vertex, but that is the vertex because there's symmetry around that point. In fact, if I were to go to this 0 right here, do you know what my y is going to be? Because I do. Probably like 6. And if I go to -1, you know what my y is going to be right here? What is it? 16, because there's what? Symmetry, right? Those should be the same. And I can actually check this pretty easily because I got a table. So I'm going to look at my rate of change. Do I have a linear additive rate of change? Sure enough. Right, so I know those points are correct, but notice there is symmetry around this point. You can see it if you graph it, but now I can use either form. Choose your own adventure. I don't care which one you go with, but I want you to I want you to write the equation for this quadratic function. Don't forget, you don't have to make a table, or you don't have to use a table, you can use a graph. You can identify your roots, you can identify your vertex, whatever you want to do. Let's get to it. About 10 more minutes to get as many of these done as possible before we start our demonstrate your understanding. Davey, you good? You look like you're like unsure. You just tired or are you scared? You don't know which one? We got this equation after solving for A. And I asked, hey, how could you check yourself? And one group said, well, we could graph it, right? However, do you have a graph? No, right? There's no graph there. But these should be equivalent. What do you know about equivalent functions, about their inputs and their outputs? Same inputs mapped to the same outputs. So if I substitute 4 in, what should that map to? So, a couple of things to remember here. X is 4. Notice, did I put 6 here? Because I've seen people putting 6 right here. No, 4 is my input. And if I substitute 4 in, what should I be getting out? Alright, what's 2 squared? 4. 2 times 4 is? And what's 8 minus 2? So did I get the correct output out? The same input mapped to the same output. If I check it here, right, my output again is 6. 4 minus 1 times 4 minus 3. What's 4 minus 1? 3. What's 4 minus 3? And what's 2 times 3? Times 1? So the same input mapped to the same output. So use your understanding of equivalency to show that they are equivalent. One, it's going to help you be certain, not have confusion if you got it right or wrong. Two, even if you get it wrong, does this tell me that you understand some really important ideas? Show me evidence of your understanding. Okay? Now, clear your desk of everything. I do say everything. I apologize that this demonstrated understanding has hole punches on both sides. Mr. Hobby, yeah, he punched hole punch on the wrong side. It happens. Okay. You have the rest of class to demonstrate your understanding. By the way, again, no calculators, because you could quite literally just type this equation into the calculator and get those features. I want you to clearly identify the features of these parabolas based on the equations. Now, a couple of things to keep in mind in this. You do not have to do all of these questions. What you have to do is 2A. 2B is if you want to try to hit the exceeds portion of the proficiency scale. You have to do 3A, so make a note on 2B, you don't have to do that. 4B, you don't have to do that, but that can get you to the exceeds portion. 4C and 4A you need to do, right? Last detail with 5 and 6, if you don't know how to do the calculations, you want to check to make sure that you have done the calculations correctly. Like you set everything up, but maybe you're like, oh, Mr. Kinney, I don't remember what 8 divided by 2 is. That's okay, come to me and I will help you do calculations since you don't have a calculator. Does that make sense? Okay, so again, those that I identified are just to help you get to the exceeds, right? So 4B, 2B, you don't have to do those to the exceeds, but let's use the rest of the time that we have to do this demonstrate understanding. And I gave you number 1 to help you out. Please write those equations to get started. Yeah. Yeah, that was Preston. He'll come back for it today. Also, don't sit there and struggle with a question you don't know. Do all the ones you know how to do first, quickly and efficiently. Bless you.